Two continents, 82 kilometers of freezing water between them. For over a century, engineers have dreamed of connecting them with a tunnel. Estimates range from $8 billion to over $200 billion for a tunnel longer than any ever built, under one of the most hostile environments on Earth. Just months ago, Russian officials proposed using Elon Musk's Boring company to cut the traditional cost by nearly 90%. But the Bering Strait isn't just deep water and ice. It's a geopolitical fault line, a seismic zone, and a graveyard of failed 19th and 20th century proposals. Can engineers actually finish what a century of czars, presidents, and billionaires could not? Today, we go inside the impossible tunnel. This is the Bering Strait, kilometers of freezing water separating Asia from North America. In 1890, Colorado's first territorial governor proposed a railway tunnel here as part of a global rail network. It was rejected. In 1905, the Russian Tsar briefly approved a tunnel survey. 2 years later, his government withdrew all support. In 2007, Russian officials unveiled a $65 billion plan to finally build it and made global headlines. Engineers gathered in Yakutsk in 2011, presenting detailed blueprints for a tunnel over 100 kilometers long. Cost estimates today range wildly from $8 billion to over $200 billion, depending entirely on whose plan you believe. In October 2025, a Russian investment envoy revived the proposal, tied to renewed diplomatic talks in Alaska. The pitch: use tunnel boring technology already proven in American test tunnels to cut traditional costs by nearly 90%. Just 82 kilometers of water. Over 130 years of failed attempts. Here's why it's so hard to actually build. The strait runs from Cape Dezhnev in Russia to Cape Prince of Wales in Alaska, kilometers of open water. Halfway across sit the domed islands, one Russian, one American, just 4 kilometers apart. The international date line runs directly between them. Standing on one island, you can look almost a full day into the future. The seafloor here is shallow, only 30 to 50 meters deep, actually shallower than several undersea tunnels already built elsewhere. But the strait freezes over every winter with shifting pack ice that would crush a surface bridge. One reason engineers favor a tunnel instead. Winter temperatures drop below -40 degrees, with Arctic storms bringing winds over 100 miles per hour. Both coastlines sit on permafrost ground, frozen year-round to depths of hundreds of feet, a serious challenge for any tunnel portal. The nearest working rail line in Russia sits over 500 kilometers away. Alaska's railway doesn't reach anywhere near the strait either. The tunnel itself is only around 100 kilometers. The connecting railway needed on both sides stretches nearly 6,000 kilometers. The Bering region sits near an active tectonic boundary, with recorded earthquakes a risk most undersea tunnels never plan for. Strong tidal currents run through the strait, complicating any offshore construction work. Gray whales and walrus migrate through these waters every year, adding environmental review to an already complex project. Wales, Alaska has a population of about 150 people. Settlements on the Russian side are just as small. There's essentially no local workforce. Compare that to the English Channel, kilometers wide, mild climate, dense population on both sides. The Bering Strait is a different world entirely. The Usasha maritime border runs directly between the two domed islands. The tunnel would cross a live international boundary. Right now, neither coastline has a paved road reaching the proposed portal sites before any tunnel is dug. Engineers must build infrastructure from scratch. Enter the tunnel boring machine, a rotating cutter head over 8 meters wide, grinding continuously through rock beneath the seafloor. The design calls for twin rail tunnels running in opposite directions, plus a smaller service tunnel between them, the same layout used under the English Channel. At roughly 103 to 113 kilometers, it would be more than double the length of the Channel Tunnel, and longer than Japan's Seikan Tunnel, the longest tunnel ever built. The domed islands sit conveniently at the midpoint, offering a natural spot for ventilation shafts and emergency access straight down to the tunnel. Engineers would likely use ground freezing techniques to stabilize loose seabed sections proven elsewhere, but never before at this Arctic scale. Icebreaker ships would need to escort construction barges through seasonal pack ice just to keep offshore work moving. For months each winter, crews would work in near-total polar darkness, under floodlights, in temperatures that can be dangerous within minutes. Every ton of steel and concrete would have to arrive by cargo plane or ice road. There is no existing supply chain at either end. Workers would live in insulated fly-in, fly-out Arctic camps, rotating shifts in one of the most remote job sites on Earth. Because the region sits near an active fault zone, the tunnel lining would need seismic engineering most undersea tunnels never require. The shallow seafloor is actually an advantage less water pressure than a deep ocean tunnel, but ice scouring near shore creates its own structural risks. Remote power plants would need to be built just to run the boring machines, let alone the trains that would eventually use the tunnel. The modern cost-cutting pitch rests on tunneling technology, already proven in shorter test tunnels dug under American cities. Skeptics point out those tunnels are a fraction of the length, dug through mild ground not 100+ kilometers of Arctic seabed. There's also a basic mismatch. Russian railways run on a wider track gauge than American lines, meaning a transfer station would be required at one end. Optimistic claims put the tunnel alone at under 8 years. Most independent engineers estimate 20 to 25 years for the full corridor. The tunnel itself might genuinely be the easiest part of this entire project. The next problem is money. Cost estimates span an enormous range $1 billion by the most optimistic claim, $65 billion in the traditional plan, and up to $200 billion for the full vision. A $100 billion price tag is roughly equivalent to the entire annual economic output of a mid-sized country. The tunnel itself is estimated at only $10 to $15 billion. The rest comes from building nearly 6,000 kilometers of connecting rail, power lines, and fiber optic cable. Funding talk has come from the Russian state, its sovereign investment fund, past Chinese interest, and now a private American tunneling company. Western sanctions on Russia since its 2022 invasion of Ukraine make large-scale joint use financing legally and politically fraught right now. Millions of tons of concrete and steel would need to reach two of the most remote coastlines on the planet, with no local supply chain to draw from. This isn't the first funding promise. 1907, 2007, and several points in between all saw pledges made, and every one of them stalled before construction began. Supporters argue a rail freight link could cut shipping costs between Asia and North America, easing congestion at crowded Pacific ports. Proponents also point to Russia's underpopulated, resource-rich Far East, which a connecting railway could finally open up to development. Critics counter that freight volume along a route with almost no population might never come close to justifying the investment. The Channel Tunnel is the closest precedent privately financed, and it ran about 80% over its original budget before it ever turned a profit. Ensuring a $100 billion structure that straddles the border of two nuclear powers in an earthquake zone raises questions nobody has fully answered. The 2025 proposal was explicitly branded as a symbolic diplomatic project, as much a political gesture as an engineering plan. History shows multi-decade megaprojects almost always cost more than planned. It happened with the Channel Tunnel, Japan's Seikan Tunnel, and Kansai Airport alike. On the other hand, Proponents note the project could bring real jobs and infrastructure to two of the poorest, most remote regions of both countries. Every serious estimate agrees on one thing. No government has ever actually committed $65 billion, let alone $100 billion, to this project. So even if the engineering works and the money somehow appears, who would actually allow this tunnel to be built? U.S.-Russia relations froze during the Cold War, thawed briefly in the 1990s, and froze again after Russia's 2022 invasion of Ukraine. Security analysts have long warned that a fixed rail link could, in theory, offer a direct land route between the two countries. That fear isn't new. Some historians believed Tsarist advisors in 1907 worried the tunnel could just as easily bring outside influence into Russia's Far East. The Channel Tunnel only works because of a specific treaty allowing shared border. Checks any Bering Tunnel would need an entirely unprecedented U.S.-Russia security framework. The October 2025 proposal landed right around talk of a Trump-Putin meeting in Alaska, and briefly dominated headlines as a symbol of possible reconciliation. Reactions split immediately. Some called it a genuine peace-building opportunity. Others dismissed it as a gesture unlikely to survive the next diplomatic downturn. China has its own interest. A 2014 proposal from Chinese engineers envisioned a high-speed rail line from Beijing to Alaska through this same strait. Indigenous Alaskan and Chukotka communities have lived and hunted across these waters for generations, and any project raises real questions about consultation and impact. The U.S.-Russia maritime boundary runs directly between the two domed islands, separated by just 4 kilometers, and by an entire geopolitical divide. Current sanctions regimes complicate any large joint venture involving Russian state-linked financial institutions. The idea has now been revived at least half a dozen times since 1890 after wars, revolutions, and diplomatic thaws, only to stall again each time. Supporters argue a shared, decades-long megaproject could force sustained cooperation, since neither side would want to abandon a half-built tunnel. Critics respond that neither government has ever actually appropriated meaningful funding, no matter how warm the political mood. Public reaction to the 2025 proposal ranged from genuine excitement about peace infrastructure to outright disbelief it could ever really happen. Unlike the Channel Tunnel's partnership between two allied, similarly sized economies, the US and Russia remain strategic rivals with fundamentally different political systems. Here's the paradox. This tunnel is closer to technologically feasible today than at any point in its 130-year history, but politically, it may be further away than ever. So what does history actually tell us about tunnels this ambitious? 2 real examples, one triumph, one warning. In 1990, tunnel boring machines from England and France met in the middle of the English Channel, one of engineering's genuine triumphs. The Channel Tunnel was originally budgeted around £2.6 billion. Final cost, roughly £4.65 billion, about 80% over budget. Today, hundreds of trains pass through it daily, and it's been profitable for decades, proof a binational megatunnel between allied economies can work. Japan built the Seikan Tunnel after a 1954 ferry disaster killed more than 1,000 people, finally forcing the government to commit to a permanent fixed link. At 85 kilometers, Seikan took roughly 24 years from initial survey to opening in 1988, plagued the entire way by water leaks and cost overruns. It remains an engineering marvel, but actual train traffic came in far below original projections, a lasting lesson in overestimating usage. Kansai International Airport was built on an artificial island in Osaka Bay to solve a land shortage, opening in 1994. That island has sunk far more than engineers predicted because of soft clay on the seafloor, requiring billions of dollars in ongoing reinforcement ever since. The lesson: get the geology and long-term settlement calculations wrong on a megaproject, and it costs billions for decades afterward. Every megatunnel that actually got built shares three things: a clear practical need, sustained political will, and a funding plan tough enough to survive setbacks. The Bering Project currently has ambitious technology claims and occasional bursts of political enthusiasm, but it has never had sustained funding from either government. History is littered with transcontinental tunnel and bridge proposals that never made it past the feasibility study stage. What's different in 2026 is a private company claiming technology that could fundamentally change the cost equation, if that claim actually holds up at 100-kilometer Arctic scale. So could this finally be the one that actually gets built? Engineering feasibility, increasingly realistic. Financial feasibility, wildly uncertain. Political feasibility, still the biggest obstacle by far. For this to actually happen, it would need a sustained diplomatic thaw, multi-billion-dollar committed funding, and thousands of kilometers of connecting rail built before the tunnel even starts. Even the most optimistic claims put the tunnel alone at under 8 years. Most independent engineers estimate 20 to 25 years for the entire corridor. Is a $100 billion, multi-decade project justified by trade and symbolism, or is it a monument in search of a purpose? That's still an open question. From a 1890 proposal to a 2025 pitch tied to renewed diplomatic talks, this idea keeps resurfacing every few decades and keeps stalling at the same 2 points: funding and politics. This is the windswept coastline near a small Alaskan settlement of about 150 people, where a portal to a $100 billion tunnel might one day stand. Across the water sits an equally empty stretch of Russian coastline, facing back across the strait. 4 numbers define this story: 82 kilometers of water, over 100 kilometers of proposed tunnel, more than a century of failed attempts, and a price tag anywhere from $8 to $200 billion. Under the midnight sun of an Arctic summer, this narrow strip of water still separates 2 continents and 2 very different visions of the future. Will engineers finally finish the Bering Strait tunnel, or will it remain the greatest infrastructure project never built? Let us know what you think.